I'm going to share with you the graphs of several examples for sine and cosine, given this new idea of displacement. And once you get the hang of it, please just pause the video, do the problems, and then whip through them and see how you did and compare with my answers. So after this one, this first one's relatively simple. The next one's a little bit harder, and the one after that harder as well because of the fractions that are involved. And I do expect you to work with these fractions. So first of all, the amplitude is always the number in front of the sine or cosine of x. So the amplitude of this function is 3. I meant to do this in black. The period is 2 pi divided by the coefficient in front of x. So remember, this number is your b value. It's what's in front of x. So 2 pi divided by 4, and you reduce 2 over 4. That's 1/2. 2/4 is 1/2. It's easier to just write it as pi over 2. That is 1/2 pi, but I don't tend to write that 1. The displacement is the opposite of this pi over 2. So see this minus sign right here? When I see that sign, I just tell myself that this is going to be displaced in a positive direction, to the right. So again, I had a minus pi over 2, so I'll put down a positive pi over 2, and then I'm going to divide by what's in front of x. If it's just a whole number, I always write it as 4 over 1, so that when I go to do my arithmetic with fractions, so here's a place where our use of adding, subtracting, multiplying, and dividing fractions is very important. So when I divide by 4, I multiply by 1/4, and I have the displacement for this curve as pi over 18. Again, it's a positive pi over 18. You know, I said it was important just a minute ago, and you've seen the applications already of light and sound in class, and we're going to do even more after we finish this section. And it really is, and there's more than just light and sound in terms of waveforms. So to people in general, the world over, these waves are important to our lives. In this case, you know, noise-canceling headphones, a lot of people have them, and it's going to become pretty common technology. All right, when you go to graph this curve, the displacement is pi over 18. So just pick a spot, any spot. Just pick it to the right of the y-axis. You know, where you put it, if you're particular, and I am, will become a little bit more apparent later as to how hard that is. But we'll talk about it as we go. Then what I do is I go ahead and draw the sine curve in, and it's a positive 3 as the amplitude. So I go ahead and draw upward, and then underneath, and stop right here, and this is where I end that curve. Remember, there are 4 important quarter points. I can no longer put the period right here, pi over 2. I can't do that because I didn't start at 0. I started at pi over 18. So what I have to do now is very, very important, and that is that I have to take 1/4 of the period, because each of those quarter points are equally spaced a quarter of the whole distance that it takes to travel through that one cycle. So a quarter of pi over 2, which is the period, is pi over 8. So the distance from here to here, you know what, I see an error that I have, and I'm sorry if it's been bothering you all along, but I'm not going to redo. This right here, pi over 2 times 1/4 should have been pi over 8. So let's see if I can erase that. I put 18. Geesh, my apologies. So this is pi over 8, and this is also pi over 8. So I'll erase that. And now I'm good to go. And the reason I noticed it is I knew that the displacement was pi over 8, and I had already preconceived that the quarter of the period was pi over 8. So I have to add to this starting point a value of pi over 8. And I'm going to try to do it lightly. So I'm going to add to this pi over 8 to get to that spot right there, because this is a quarter of the period. Well, 1 pi and 1 pi adds to be 2 pi over 8. Yes, that should be reduced. But I'm not going to bother right now because I want to keep having common denominators. If I reduce that to pi over 4, then I can't add 2 pi and 1 pi to get the next spot, which is 3 pi over 8. And the next spot, I want to add pi over 8 to it as well. So 3 pi plus 1 pi is 4 pi over 8. Yes, I want to call that half pi, but not right now, I don't. And then I'm going to add pi over 8 to that as well, and I'll have 5 pi over 8. Again, this one could be reduced to pi over 4. This one right here could be reduced to pi over 2. This one can't be reduced. But what you could do is you could go to your ending point and back to your beginning point and see if you took that end point and subtracted your starting point. 5 pi over 8 minus 1 pi over 8 is 4 pi over 8, which reduces to half of pi, or pi over 2, and see if the distance from here to here is 1 full period, pi over 2. It is. Boy, I apologize for that. 18, that's kind of poor. Hope I didn't distract you. A harder problem. So this is harder for 2 reasons. It's got a plus sign right here, so it's going to shift to the left. That's okay, but it's no question, it's harder. It's got a minus sign in front of that 4, so be careful. It's a cosine curve that's got to start low, not start high. Let's go ahead and fill in the data. Remember, I like to put the negative sign down for the amplitude so I can see it, even though it says what's the absolute value of A. So the amplitude of this curve is 4. I just do this for myself so I can kind of blare out here, Pat, don't forget to draw this upside down. Then I'll take 2 pi and divide it by the coefficient of x, which is this 3, and there's nothing to be reduced. Now I'm going to take the opposite of that sign. So I'm just going to put the negative sign on the pi over 3, and then I'm going to divide by this 3 again. Would you notice that the period is divided by b and the displacement is divided by b? So sometimes I'll peek up here and say, oh, you divided by 3. So you got to divide by 3 again. But in this case, I'm going to write it as 3 over 1. So I don't forget to multiply by 1 over 3. And so the displacement of this curve is a negative pi over 9. We're ready to graph it. So I've got to start to the left of the y-axis at this negative pi over 9. And, this is where it's, for me, particularly hard to decide where to put that. But I just got to pick something. So I'm going to go ahead and do it. Negative pi over 9. And remember, the amplitude of this curve is a negative 4 and a positive 4. So I have to start this curve at this negative pi over 9, and it's a cosine curve. Cosine would normally start here because of the negative 4. It's going to start right here. And then it's going to go upwards somehow. And this is what I don't know. Where is it going to hit this x-axis? Then it's going to top out at 4. Then it's going to come back down. And then it's going to finish, and it would repeat. But this is where one full cycle stops. So I started here, I ended here. If I went on to do another cycle, it would look like this. And I'd put some arrowheads. Again, don't forget, it can go that way as well. But what I would like you to do now is I'd like you to get this point, this point, this point, and this point. Be careful. You could get this final point by starting here and adding the period to it. Absolutely. You could do that. I am in favor of always taking 1/4 of the period, and I always do this in red, whether I'm in class or making videos, because I really want you to see this boldly. So 1/4 of the period, which is 2 pi over 3, is 2 pi over 12, and 2 pi over 12 reduces to 1 pi over 6. This is kind of a key data point, just a very key amount. It's the amount I'm going to add to this number to get to here. And then once I get this number, I'm going to add that pi over 6 again to get to here. And once I have this number, I'm going to add that pi over 6 again to get to here. And once I have this, I'll add that pi over 6 again to get to here. So I like to kind of create a little table format. So I have a starting point of a negative pi over 9. That's right here. I got to add 1/4 of the period to get to there. 1/4 of the period is pi over 6. Shoot, these don't have common denominators. So I got to make them 18s. So between the 9 and the 6. So I'm going to multiply this one by 2 and I multiply this one by 3. So they become, the first one is a negative 2 pi over 18. That pi over 6, which is very, very important, is 3 pi over 18. And when I add these together, they have a common denominator. These are just like terms. A negative 2 pi plus 3 pi is 1 pi. You don't need to write that 1. I just like to write it down initially. So it's just 1 pi over 18. That's this spot right here. I've got to add a quarter of the period to this point to get to here. The period was pi over 6. But we called it 3 pi over 18. So this pi over 18 where I just ended, I have to add 3 pi over 18 to it again to get to the next stop, 4 pi over 18 right here. Yes, I should reduce that. I should call that 2 pi over 9. But I don't want to yet because I got to keep these common denominators going. So now I'm going to take this 4 pi over 18 and add that. See this 3 pi over 18, 3 pi over 18? I keep adding 3 pi over 18. This is the hardest part to these problems. And I get 7 pi over 18 for this spot right here. Could you go again without me writing down the last step? So I was at 1 pi, I added 3, I got to 4 pi. I added 3 again, I got to 7 pi. I add 3 pi again to this, and I get to 10 pi over 18, and I should come back and reduce that by 2, each of those, top and bottom, so 5 pi over 9. Finally, this 5 pi over 9, my ending point, and this beginning point, if I took my 5 pi over 9, and I subtract the negative number, because when I subtract, I want to find the distance between the two. So essentially, I'm taking this 5 pi over 9 that goes from here to here, and I'm adding this pi over 9. I'll be adding that, because when you subtract a negative, you add. And so 5 pi and 1 pi is 6 pi over 9. And I reduce that, and that's 2 pi over 3. Go back and look at your period. See if this is indeed your period. So now you know that from here to here turned out to be 2 pi over 3, and you have your quarter points successfully. I'm going to stop there. I'd have you practice number 3 on your own and come back and see how you did.